forgot to record, but people will hopefully be able to pick up from here. 37-degree angle. Any thoughts on what the reference angle is there? Not a trick question. It's 37 degrees. I mean, it's just the angle formed against the x-axis. Okay. So 37 degrees is the reference angle. Try a D, E, and F on your own. Try D, E, and F on your own. Question? Got 18, 85, and 85. Is that what you got? Any questions on any of those three? Okay. We'll do one more. We'll skip the negative ones because they don't really come up. 181 degrees. Anybody want to suggest what the reference angle is going to be there? 79? It's definitely, it matters which one we choose. Is it 79 or is it 1? It's always formed between the x-axis. So you're kind of looking here. Again, it's between the x-axis. So not 79. You would probably be thinking 89. It's, yep, that's all right. It's 1 degree. 1 degree. Always between the x-axis. Never go to the y-axis. Okay, so you have a general idea of our reference angles. The second thing we need to do before we talk about solving the angles is we need to be able to talk about, or solving the equations, we need to talk about where sine, cosine, secant, cosecant, tangent, cotangent are positive and negative. So here's what I'm going to do for you. We need to kind of think about this. The coordinates in the first quadrant are positive and positive. How about in the second quadrant? What do we have? Good, negative, positive. Third quadrant? And in the fourth quadrant? Good, positive, negative. Not necessarily -1, positive, negative. So when we try to determine where things are positive and things are negative, we think about their, their values as variables. I don't know if you recall this, but we said that sine was the y value of the terminal point, and cosine was the x value, and tangent was y divided by x. That was kind of one of the first things we did in trigonometry back at the beginning of the third quarter. Do you have a vague memory of that? So if sine is the y value, will sine be positive or negative in the first quadrant? It'll be positive. How about cosine? Positive. How about tangent? Positive. Let's move over to the second quadrant. Is sine going to be positive or negative in the second quadrant? Positive. How come? Because the y value is positive. How about cosine, positive or negative? How come? Because the x is negative, so cosine is negative. How about tangent? Tangent is negative as well. Because if you take a positive divided by a negative, you get a negative. Let's move to the third quadrant. Is sine going to be positive or negative? Sine is negative because you see that the y value is negative. How about cosine? Cosine's negative. And tangent would be negative as well, right? Everything's negative in the third quadrant. Why? Because negative divided by negative is positive. Very good. So tangent's positive over here. And then I go to the fourth quadrant. Sine positive or negative? Sine's negative. How about cosine? Cosine's positive because the x value is positive. And tangent? Tangent's negative. So what we've learned is that sine and cosecant, they are positive in the they're positive in the first and second. They're negative in the third and fourth. Positive in the first and second, negative in the third and fourth. How about cosine? Positive in the first and fourth, and negative in the second and third. And how about tangent? First and third, negative in the second and the fourth quadrants. Think you can memorize that? Nope. Okay. So I try to think of it that the y values are positive above, so that's why sine is positive up. The x values are positive to the right, that's why cosine's positive to the right. And then tangent's positive where you have those same signs. And so that's how I try to think of it. But here's the tactic that many students have used throughout the years. I didn't learn this, but this is what a lot of students do use. I would say a lot of students use this here. And they learn this acronym. All students take calculus. True statement, right? Devarian, you're going to take calculus at college, right? Thank you, I appreciate that. All students take calculus. Why does this help us remember where they're positive? All of them are positive in the first. Which one's positive in the second? Sine. Which one's positive in the third? And the fourth, you see cosine. All students take calculus. And once you know where they're positive and which ones are positive, it can then help you determine the others. So I won't make you memorize that. I'll give you those pieces on the test so you can see where they're positive and negative. But now we are ready to start our solving of these equations. It would be good for you if you had a calculator of some sort at this point. You can't really solve these without a calculator. Okay. So I want to solve this equation, and I'm going to come up with solutions between 0 degrees and 360 degrees. A for the day, who can tell me how I might start by solving this equation? Yeah, I add 1. Yep. 2 sine of theta is equal to negative 1. What do you think I do now? Divide by 2. So, not too complicated so far, right? Now what we need to do is we need to, solve for theta, okay? And this is where it gets just a little bit more involved. And here's what I do. I set up some quadrants. Okay? And I see that is sine positive or is sine negative? Sine is negative. Everybody agreed? This is the critical part. You will not know how to do it unless you follow this piece. Sine is negative. Everybody agreed? So look, which quadrants is sine negative? 3 and 4. Everybody see that? So I have to go back and reference. Once I've referenced that, what that means is I'm in the third quadrant and I'm in the fourth quadrant. And I draw those reference angles there. Okay? You may say, I don't know how big to make the reference angles. Doesn't really matter. Just make some reference angles. And then we go to our calculator. Does everybody see that we're solving for an angle? Do you remember what you press in your calculator when you're finding an angle? Second sign. And here's the last trick. Please do not type in the negative. We've already determined where it's negative. We've used the negative up. Don't type the negative again. Just type in 0.5. And you'll get that. What that means is I have a reference angle of 30 degrees. 30 degrees here and 30 degrees here. The answer is not 30. If this is a 30-degree angle here, then how many degrees is this? Try this again. How many degrees is that? Close. 210, right? We're going to take an 180 and do what? We're going to add 30, right? Everybody see that that's 210 then? Good, so 210 degrees. So what would the other one be? $330. This is 0 degrees. This is 90. This is 180. This is 270. This is 360. So you can see here that your answer is going to be between 270 and 360. You can see here that your answer is going to be between 180 and 270. See that? So those are my two answers. So it's new, but we don't have to make it super challenging. Okay? Let's try the next one. Okay? -5 cosine of theta plus 1 is -2. What we're going to start by doing? Subtract 1. And I get -5 cosine of theta is equal to -3. Divide by -5, so cosine of theta is equal to 3/5. Everybody okay with 3/5? At this point, you have to draw your quadrants. Is cosine positive or is cosine negative? Cosine is positive. Where is cosine positive? Which quadrants? 1 and 4. So I draw an angle in 1 and an angle in 4. What do I do next? Good. Second cosine of 3 divided by 5. 53.13. Again, it always goes against the x-axis in the side, okay? Never against the y-axis, always against the x-axis. So we'll start with the easy one. What is that angle? Yep, 53.13. What would I do to compute that angle? 360 minus 53.13. Good. And I get 306.87 degrees. So do you understand that your solutions are sometimes in the first quadrant, sometimes in the second, sometimes in the third? You don't always know, do you? Okay. This is going to be a 2-day lesson, okay? So we're going to spend more time on this tomorrow. You guys are doing a good job, okay? But let it soak in a little bit today, and tomorrow we'll really solidify it. How about this one, number 3? Subtract 5. So I have negative 6 times the tangent of theta is equal to negative 8. Divide by negative 6, so tangent of theta is equal to 8 over 6, or 4/3. So on the test, everybody can get that far, right? So out of 3 points, I give you 1 point right now. Okay, got 1 point. Let's try to get some more points. What should I draw? My quadrants. What's that? 1 and 3. Why? Tangent is positive in 1 and 3. Good job. Now what? Good. Second tangent of over 3, and we get 5313 again. Isn't that interesting? You now have 2 out of 3 points on the test. Okay, you came up with this, and then you were able to actually find, kind of your reference angle on the quadrants. So to get your third point, you have to actually come up with theta. So I'm going to look at the first angle, which is going to be 53.13 degrees. And then how would I go about computing that angle? Add 53.13 to what? To 180. 180 plus 53.13, you get 233.13 degrees. When you came up with answers in algebra, when you're solving equations, how did you check your answer? You plugged it back in. And if I take negative 6 times the tangent of 233.13 and I add 5, hopefully I'll come up with an answer very close to negative 3. And as you can see, the rounding does play, it does cause some error, but we come up with basically negative 3. So the nice thing is, too, you can always go back and check your answers. We're going to spend another day on this. If you would like to start by trying a couple problems on your assignment, so be it, but we are going to have some time to work on tomorrow as well. If you'd like to take the rest of the day and just sit quietly and visit, you can do that too. Good job.